Hello everyone, welcome back to mathematics online classes. So in previous class we have studied Cartesian product, relation, in particular definition, domain, range, codomain of a relation and representation of relation in arrow diagram. Okay, so let us study next concept and few problems. Let us discuss next problem on this relations. Suppose A is equals to 1, 2, 3, B is equals to 4, 5, even I will consider 3, 4, 3, 4 and R is equals to ordered pair x comma y such that x belongs to A, y belongs to B, comma x is equals to y, comma x is equals to y. So first write roster form, write domain, range, codomain and write arrow diagram. Okay, so first of all let us write its roster form. So what will be the roster form of this? R is equals to, here the relation is from A to B. Clearly we can observe the relation is from A to B. Therefore Cartesian product will be 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. In those Cartesian product elements, we need the elements in which first element is equals to second element. Therefore, clearly it is R is equals to 3, 3. R is equals to 3, 3. Okay. So now, what is domain? Domain is singleton 3. Range is also singleton 3. And what will be codomain? Codomain is this second set B itself. Therefore, it is 3, 4. Codomain is 3, 4 and arrow diagram representation will be 1, 2, 3. Here it is A, here it is B. 1, 2, 3, 3, 4, 3, 4. Therefore, this is arrow diagram representation of this particular relation. Next problem. Let A is equals to 1, 2, 3, 4, 5, 6. A is equals to 1, 2, 3, 4, 5, 6. Define a relation R on A. Define a relation R on A given by ordered pair A comma B. Here I will consider ordered pair A comma B such that A belongs to A, B belongs to A, B is exactly divisible by A. B is exactly divisible by A. So here again we need to write its roster form, domain, range, codomain and arrow diagram representation. Okay. So now first of all let me write it in roster form. So which kind of ordered pairs we need? A belongs to A, B belongs to A means it's a relation from A to A. First of all, this should be the conclusion of this problem. This relation is from A to A. Sometimes they will mention define a relation from A to A, or simply from this condition. From this condition we can observe this relation is from where to where. Okay, R is equals to. So which ordered pairs we need? B is exactly divisible by A. In your mind you should have the rough calculation about the Cartesian product A cross A. A cross A will contain 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Next it will be 2, 1, 2, 2 up to it will be 6, 6. Therefore, in those ordered pairs, B is exactly divisible by A. So let me consider 1 comma 1 because this 1 is exactly divisible by this 1. Next 1 comma 2 because this 2 is divisible by 1. Next 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6. Next, so if you consider next element 2 comma 1, if you consider 2 comma 1, then what happens? 1 is exactly divisible by 2, but which is not true. Therefore you should not consider this 2 comma 1. Therefore next element will be 2 comma 2, next 2 comma 4, next 2 comma 6. So similarly this 2 comma 1, 2 comma 3, 2 comma 5 will not be there in this particular relation, even though it will be in the Cartesian product. Relation is a subset of Cartesian product. Next 3 comma 3, 3 comma 6. Next 4 comma 4, 5 comma 5, 6 comma 6. These are the elements in this particular relation. So what will be domain? What will be domain? You can clearly observe all the elements of this set A is first element of some ordered pair. Therefore it is 1, 2, 3, 4, 5, 6, which is equals to A itself. Okay, which is equals to A itself. Let me write which is equals to codomain, which is equals to range also in this particular problem. So domain, codomain, range all are same. Okay, so next arrow diagram. This is A, this is also A. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. From 1, 2, 3, 4, 5, 6. From 2 it is 2 to 2, 2 to 4, 2 to 6. From 3, 3 to 3, 3 to 6. From 4, 4 to 4. From 5, 5 to 5. From 6, 6 to 6. This is arrow diagram representation of this particular problem. Next concept is functions. Functions are also called as special relations. Okay, so special relations means if you give some extra condition to a relation, then it becomes a function. If you give some extra condition to relation, then it becomes a function. Okay, so let me define function. A function, sorry, I will consider a relation f from A to B. F from A to B is called function. Is called function if every element in set A, if every element in set A has one and only one image, one and only one image in set B. In set B, a relation f from A to B is called a function. If every element in set A has one and only one image in set B, or a relation f from A to B is called a function if every element of set A is uniquely associated with an element in set B. With an element in set B. Or you have one more definition, or if A comma B belongs to F, then for any element C, A comma C should not be belongs to F. If A comma B belongs to F, then A comma C should not be belongs to F for all first elements in this set A. So before I am giving the examples, the definition of the functions will not be very clear. So once I will explain these definitions again, and immediately I will be moving into examples. Okay. So first one is, a relation f from A to B is called a function if every element in set A has one and only one image in set B. We all know what is image. Okay. In relations we have discussed image. So if you have A comma B, this B is called image of A. This B is called image of A. If every element in set A has one and only one image in set B, or every element of set A is uniquely associated with an element of set B, or if A comma B is belonging to F, then A comma C should not be belongs to F. Or more precisely, let me make a correction here. It's not a function. A relation is not a function if A comma B belongs to F and A comma C also belongs to F. So the same definition I have considered in different manner. A relation is not a function if A comma B belongs to F, A comma C also belongs to F. Okay. So let me consider examples. Suppose A is equals to 1, 2, 3, B is equals to 4, 5, B is equals to 4, 5, R is equals to 1, 4, 2, 4, 3, 5. Is it a function? Definitely it's a relation. Definitely it's a relation from A to B. My question is it a function? Is it a function from A to B? A to B ಗೆ ಇದೊಂದು ಫಂಕ್ಷನ್ ಆಗ್ಬೋದಾ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಸೊ ಫಂಕ್ಷನ್ ಆಗಬೇಕು ಅಂದ್ರೆ ರಿಲೇಷನ್ ಹೌದಾ ಅಲ್ವಾ? ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ರಿಲೇಷನ್ ಹೌದಾ ಅಲ್ವಾ? ಸೊ ಈಸ್ ಇಟ್ ಎ ರಿಲೇಷನ್? So if you consider A cross B, definitely it contains 1, 4, 1, 5, 2, 4, 2, 5 like this. Definitely this R is a subset of that Cartesian product. Therefore it's a relation. So whether it's a function or not, to identify a relation is function or not, the very beautiful idea regarding this will be arrow diagram. The very beautiful idea will be this arrow diagram. You have a set A, you have a set B, and you have 1, 2, 3 here, and you have 4, 5 here. Then 1 to 4, 2 to 4, 3 to 5. Now let me again move back into my definitions. A relation is a function if every element of set A, in more precisely, a relation from A to B is called a function from A to B if every element in set A is uniquely associated with an element of set B. Now, or I have one more type of definition. I have explained two definitions. Every element in A have one and only one image in set B. Okay, I have two different types of definitions. Now, 1. So 1 is an element of A. So whether it is uniquely associated with an element of set B or whether it is having one and only one image in set B, definitely image of 1 is 4. Even we call this 1 as a pre-image of 4 also. If ordered pair 1, 4 belongs to a function, then 1 is the pre-image of 4 and 4 is the image of 1. Okay. Now, image of 1 is 4, image of 2 is 4, image of 3 is 5. Now, every element in set A is having one and only one image in set B. You think like 4, this 1 connects to 4, 2 connects to 4, no problem. So again I will explain, every element of A is having one and only one image in set B. I will give an example, a relation which is not a function, okay. I will give you an example. Suppose if it is A and it is B, then this is 1, 2, 3, this is 4, 5. Now 1 to 4, 1 to 5, 2 to 4, 3 to 5. This one will not become a function. Why? Because 1 is having 4 as the image as well as 5 as the image. One and only one image condition is not satisfied here. Therefore, this is not a function. That's why I said this arrow diagrams will give us beautiful idea about a relation is function or not. Okay. So, this is not a function because 1, 4 also belongs to F. 1, 5 also belongs to F. So, that is what the third definition I have considered. If A, B belongs to F, A, C also belongs to F, then it is not a function. Okay. So, now let me draw few arrow diagrams. So, that may be relation. Okay. So, that may be the arrow diagram of relations. You need to identify which one are functions and which are not functions. So, first A, this is A. Whether A is a function from A to B, definitely these all are relations from A to B. All these A, B, C, D are relations from A to B. So, which one are functions and which are not functions and why? So, first one, is it a function from A to B? Yes, definitely it's a function from A to B because every element of a set A having one and only one image in set B. Okay. Next, this B. So, whether it is function, image of 1 is 4, image of 2 is 4, image of 3 is 4, image of 4 is 6. Okay. So, is it a function? Is it a function? Yes, definitely it's a function because different elements, this 1, 2, 3, 4 have one and only one image. Image of 1 is 4, image of 2 is 4, image of 3 is 4, image of 4 is 6. You look like this 4 is the image of 1, 2, 3, no problem. We say every element of set A should have one and only one image. Okay. So, this is a function. Next, is it a function? 1 to 3, 2 to 4, 3 to 5. So, students feel like yes, it's a function. No, it's not a function because there you have two words. Every element in set A should have one and only one image in set B. But here this 4 is not having any image. So what is the condition for function? Function ಆಗಬೇಕು ಅಂದ್ರೆ ಏನು ಕಂಡೀಷನ್ ಆಗಬೇಕು? ಒಂದೇ ಇಮೇಜ್ ಈ ತರ ಒಂದು ಹೋಗಿರಬೇಕು. ಒಂದು ಎಲಿಮೆಂಟ್ ಇಂದ ಈ ತರ ಒಂದು ಹೋಗಿರಬೇಕು. ಎರಡೂನು ಹೋಗಬಾರ್ದು, ಒಂದು ಹೋಗದೇನೂ ಇರಬಾರ್ದು. ಇದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಕಂಡೀಷನ್ ಫಂಕ್ಷನ್ಗೆ. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಇದು ಒಂದೇ ಎಲಿಮೆಂಟ್ ಇಂದ ಎರಡೆರಡು ಏರೋಸ್ ಹೋಗಬಾರ್ದು, ಎಲಿಮೆಂಟ್ ಹೋಗದೇನೂ ಇರಬಾರ್ದು. ಎಕ್ಸಾಕ್ಟ್ಲಿ ಒಂದು ಏರೋ ಹೋಗಿರ್ಬೇಕು. ಒಂದು ಎಲಿಮೆಂಟ್ ಇಂದ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಒಂದು ಏರೋ ಹೋಗಿರ್ಬೇಕು. ಇಲ್ಲಿ ಒಂದೇ ಎಲಿಮೆಂಟ್ ಇಂದ ನೋಡಿ, ಇದೆಲ್ಲ ಬೇರೆ ಬೇರೆ ಏರೋ, ಇದು ಒಂದೇ ಎಲಿಮೆಂಟಿಗೆ ಹೋಗ್ಬೋದು. ಒಂದು ಎಲಿಮೆಂಟ್ ಇಂದ ಈ ಎಲಿಮೆಂಟ್ 3 ಅನ್ನೋ ಎಲಿಮೆಂಟ್ ಇಂದ ಒಂದೇ ಏರೋ ಹೋಗ್ತಾ ಇದೆ, ಒಂದೇ ಎಲಿಮೆಂಟಿಗೆ ಹೋಗಬಾರ್ದು ಅಂತ ನಾವು ಹೇಳಿಲ್ಲ. ಒಂದು ಎಲಿಮೆಂಟ್ ಇಂದ ಎರಡು ಏರೋ ಹೋಗಬಾರ್ದು. Okay, so now this D. So is it a function? Yes, definitely it's a function. 1 to 3, 2 to 3, 3 to 3, 4 to 4. One element, one arrow. But if it is 4 to 6 also, if it is 4 to 6 also, then it is not a function because this 4 is not having one and only one. One and only one means it is not 0, it is not 2, it is not 3, it is 1, one and only one. Meaning of one and only one is one and only one means only one image should be there. But this 4 is having 3 as image and 6 as image, therefore it is not a function. So again I will explain you the definition of a functions in 3 different definitions. First one is a relation f from A to B is a function. if every element of a set A has one and only one image in set B. Next, second definition is a relation f from A to B is a function if every element of set A is uniquely associated with an element of set B, or if A comma B and A comma C both belongs to the relation, then it is not a function. Okay, so this is the examples for functions in arrow diagram form. This same arrow diagram form can be written in roster form also. This will be 1 comma 3, 2 comma 4, 3 comma 5 and 4 comma 6 and 4 comma 6. Okay, so this is roster form and this is arrow diagram form. So let us discuss domain, codomain and range of a function. Already we have discussed domain, codomain, range and even image in relations. Now let us discuss it in functions. Okay, so if a function f is from A to B, so this is the notation f from A to B, a function f from A to B. This should be pronounced as function f from A to B, a function f from A to B. Then this first set A itself is called domain. The first set A itself is called domain. The second set B itself is called codomain. Okay, so codomain is same in case of a relation, but domain in relation we say the set of first elements in the ordered pair, but in this function we say this first set itself is domain. Why? Because here the ordered pair means all the elements in set A will be there in the first element in ordered pair, because if any element is not there then it will not become a function. For example, if 1 5, 2 5, 3 6, only 3 6 is there, 4 is not associated, 4 is not the first element of any ordered pair, then it is not a function. Therefore, already if it is a function from A to B, then all these elements will be the first element in some ordered pair. Therefore, this set A itself is called domain. This second set itself is called codomain. What will be range? Range of a function is the set of elements in B. The set of elements in B which are images of at least one element in set A, or you can say images of elements in set A, or you can say the elements which are having association with the elements of set A. Again, let me repeat the definition of range. Range is the set of elements in set B which are the images of the elements of set A, which are the images of elements in set A. For example, here 8 is not the image of any element. 8 is not having any pre-image. Okay, 8 is not having any pre-image, or 8 is not the image of any element. Therefore, 8 will not be in the set of range. So here if you consider domain, here domain 1 2 3 4, this is domain, this is domain. Codomain will be set B 5 6 7 8, 5 6 7 8, and range. Which elements are having association with set A? Only 5 6 7. Therefore 5 6 7. Therefore, again you can conclude that this range is a subset of codomain. Range is always a subset of codomain. At the max, all the elements in this codomain may be present in range. Okay, otherwise it will be a subset of this codomain. Next, using this concept, we define one or two types of functions, that is real function and real valued function. Real valued function, a function whose range is either R means set of real numbers, or a subset of R, is called real valued function. So what is real valued function? A function whose range is either R, total R, or subset of R, then it will be real valued function. So further, if its domain is also R or subset of R, then we call it as real function. So very simply, real valued function means a function whose domain is R or a subset of R. Real function means a function whose domain as well as range both are either R or a subset of R. The difference is, here in this real function, both domain and range both are R or a subset of R. In real valued function, only range is either R or subset of R. So using this definition, we solve many problems of finding domain and ranges. So let us consider these problems. Find domain and range of following real functions. So if they are real functions, what is the meaning of real function? Both domain and range are either R or a subset of R, but here I have considered only finding domain. Now f of x is equals to root of x minus 1. This is a new notation, okay? So f from a to b, if a function is defined from f to b, then we write y is equals to f of x. Then y is equals to f of x. Okay, so y is equals to f of x means x is input, y is output. So in arrow diagram, that is what I have explained. Suppose if you have y is equals to f of x is equals to x plus 2, y is equals to f of x is equals to x plus 2, then I will consider here 1, 2, 3. If I consider 1, 2, 3 as inputs, this is A, this is B. So if you give 1 as input inside f function, this is input, x is input. What will be the output? If you give input as 1, output will be 3. If you give input as 2, output will be 4. Input as 3, output will be 5. So this is what we write, y is equals to f of x is equals to some value. Either you can write y is equals to this or f of x is equals to this. Here we call x as independent variable and y as dependent variable. Y depends on x. So this image depends on pre-image. As pre-image changes, that image changes. Therefore, this x is independent, y is dependent. Now, from this a to b, it is 1 to 3, 2 to 4, 3 to 5. We write f of 1 is equals to 3, f of 2 is equals to 4, f of 3 is equals to 5. We write like this. Okay. So meaning of this is, under this function f, if you give the input as 1, output will be 3. Input 2, output 4. Input 3, output 5. Okay. So this function in day-to-day life also, everything will depend on a function. Everything works on a function. Okay. So from the morning itself up to tonight, if you consider anything, all depends on function. So if you are waking up early morning, it's a function. So what is that function? Waking up early. If you study, so it's a function. Studying is a function. Everybody will not study. Everybody will perform different functions depending on their lifestyle. If you are a student, you need to study. If you are going for a job, so doing that job in an appropriate manner, it's a function. Everything will works on a function. Similarly, this input-output fashion, so everything will be working on a function. So for example, if you consider a chocolate factory, it's working on a function. There is a function giving a raw material, and as an input it gives chocolate as an output. It's a function. What is the function of that chocolate factory? Taking raw material as an input, giving chocolate as an output. It's a function. So everything is a function. Without function, nothing can happen. Okay, so now here, what is the function in mathematics? What is the function? So function will give you element plus 2, whatever may be the element. This function x plus 2 means whatever may be the input you give, it gives plus 2, that element plus 2. This is this particular function f of x. So you may think f of x is equals to x square. What this function does? You give any number as an input, it gives square of that number as an output. That is, if you have 0, 1, 2, minus 1, if you give 0, 0, 1, 1, minus 1, 1, 2, 4. So this function will give square of that element. Okay, so now why I have explained this means f of x is equals to root of x minus 1. If you give x as input, it gives square root of x minus 1 as output. Okay, now this is a real function. As I said, this is a real function. Real function means domain and range both are either R or a subset of R. Therefore, when a function will not become real, so in upcoming class, in upcoming chapters, you will study one complex number chapter. And already you know that a real number is of the form p by q, where q not equals to 0. If q equals to 0, then it is not a real number. If q is equals to 0, then it is not a real number. Okay, therefore this q should not be equals to 0. Therefore, whenever you have rational form, so in this chapter itself you will study rational function. Okay, so don't worry, I will explain it afterwards. For the time being, you just remember denominator should not be equals to 0, or inside square root non-negative. I hope you know what is non-negative set. Okay, non-negative means negative numbers are not allowed. So means 0 and all positive numbers. Okay, including 0. Non-negative means including 0. So if you have root x, x should be greater than or equals to 0. These two are very, very important concept. If you have 1 by x, this x should not be equals to 0, because if x is equals to 0, that will not be in real number. It is not a real number. Similarly, if we have negative number inside square root, it is not a real number. Therefore, these two are major concepts for this finding domain and range also. Okay, if you have square root function, inside it must be non-negative. If you have this denominator term, it should not be 0. Therefore, what is the domain of this function? If you have square root under some function, that must be greater than or equals to 0. So x minus 1 greater than or equals to 0 means x greater than or equals to 1. Since it is a real function, x greater than or equals to 1 means it is closed interval 1 to infinity. Infinity should always be considered as open interval. These all concepts you have studied in sets. That's why again and again I say set theory is the base for many chapters, including this functions, relations and functions. Then this function and relations are base for many other chapters. If you don't know how to represent it in sets, okay, so how to represent it in sets, you will not understand the solution of this. In the same manner, while you move into limits, continuity, differentiability, if you don't know the definition of these basic functions or the properties of these functions, it will not be easy to understand problems. That's why again and again I say, these are the basic chapters, you should understand it clearly. So x greater than or equals to 1 means it is 1 to infinity. Here you have 1 upon x. X should not be equals to 0. X should not be equals to 0 means every real number except 0. Every real number except 0 will be the domain of this function. What is the domain of this function? So x minus 3 should not be equals to 0 means x should not be equals to 3, that is every real number except 3. Every real number except 3. Okay, so I will consider the problems on domain and range after explaining polynomial function and this rational function, but meanwhile this real functions domains are these particular. So these all are subsets of R. These all are subsets of R. That's why real function means domain and range both are either R or a subset of R, and this real valued function means range is either R or a subset of R.